Let us do the needful revision for the yesterday's class. Yesterday we have studied about the acidity of the alcohols and phenols. We have seen that both alcohol and phenol are acidic in nature and they generally react with metals and produce hydrogen gas. So when they react with metal and produce hydrogen gas, we can easily understand that they behave like an acid, and that is how we get to know that alcohols and phenols are acidic in nature. Alcohols produce sodium alkoxide and phenol produce sodium phenoxide. Uh, Alcohols and phenols are Bronsted acid, and you can see that they give, when alcohols and phenols react with the base, they give conjugate base, and the base produce the conjugate acid, and this is how we understand. When we study about the alcohols, primary alcohols are more acidic than secondary alcohol, and secondary alcohols are more acidic than tertiary alcohol. Please remember that the as compared to the alcohols, their sodium alkoxide RO minus are better base, and that is why they are such a good base that the sodium ethoxide C2H5ONA is even stronger base than sodium hydroxide. When we look at the phenols and their acidity, when we understand the various resonance structures of phenol, we come to know that among the 5 resonance structures of a phenol, 3 resonance structures have positive charge. This positive charge on oxygen pushes the hydrogen of hydroxyl bond away, and that is why it makes easy. The positive charge on oxygen makes it easy for phenol to give H plus ion easily, and that is why um, phenol is better or is more acidic than alcohols. Phenol on removal of H plus ion or hydrogen H plus ion makes phenoxide ion. And when we look at the various resonance structures of the phenoxide ion, we find that out of all these 5 resonance structures, there is no positive charge on more electronegative oxygen on the sodium phenoxide ion, and thus we can say that sodium phenoxide ion is more resonance stable because there is no positive charge on more electronegative oxygen, and that is why this phenoxide ion is more resonance stable, and the stability of phenoxide ion is more than the stability of phenol, and as phenoxide ion is more stable than phenol itself, so phenol can be easily converted to phenoxide ion by removal of H plus. It shows that phenol is more acidic than phenoxide ion. Phenol is more acidic than alcohol because in phenol we have sp2COH, but in alcohol we have sp3COH. So the aromatic group weakens the bond, and it decreases the electron density on oxygen, whereas the alkyl group uh, strengthen the OH bond by increasing the electron density on oxygen. And this is how, my dear students, we can easily understand that phenol is more acidic than the alcohol. Even when we compare these two reactions, especially the reaction of uh, phenol to produce H plus and the reactions of alcohol to produce H plus, we realize that this reaction is more easy as compared to the reaction of alcohol to produce H plus, or we can say that reaction of produce H plus by phenol is more easy than the reaction of alcohol to produce H plus, and this is how phenols are more acidic as compared to the alcohols. So as compared to the alcohols, phenols are more acidic. Now, my dear students, we want to study about the acidic characters in the substituted phenols. Yesterday, we have started studying this and we have ended with the same topic. So, let us study this topic in detail. Acidic character in substituted phenols. That means phenols which are having some other groups, and those phenols having other groups, we are going to discuss their acidic character. So now, first thing is, if phenol is substituted by electron withdrawing group, please remember, if phenol is substituted by electron withdrawing group, for example, we have nitro group. So if phenol is substituted with the nitro group, acidic character is increased. So when phenol is substituted with the electron withdrawing group, my dear students, the acidic character is increased. When this such nitro group are present on ortho position, if these nitro groups are present on ortho position or they are present on para position, the acidic character is more increased, the acidic character is pronounced. But if phenol group is present in meta position, the increase in acidity is not much pronounced, is not much as compared to the increase in acidity when the electron withdrawing group is present on ortho or para position. To understand the same, let us look at some examples. If we take phenol, if we take metanitrophenol, if we take orthonitrophenol, and if we take paranitrophenol, we would come to know, my dear students, that paranitrophenol is maximum acidic and phenol is the least acidic among all these four. And if we arrange them into the increasing order of their acidic character, we realize that phenol is less acidic than metanitrophenol. Metanitrophenol is less acidic than orthonitrophenol, and orthonitrophenol is less acidic than the paranitrophenol. Now, one more important thing which we have studied in 11th standard too, we are just going to revise this fact that the greater the pKa value, weaker is the acid. So you can see here that the pKa value for phenol is 10, but the pKa value for metanitrophenol is 8.3, pKa value for orthonitrophenol is 7.2, and pKa value for paranitrophenol is 7.1. And thus, looking at the pKa values, we can say that paranitrophenol is maximum acidic, whereas only phenol is the minimum or the lowest or least acidic in nature. So this is how, my dear students, we come to know about the acidity of the few compounds or acidity of the substituted phenol. There is one more important point that we should study, that if we look at the pKa values of phenol, the pKa value for phenol is 10. But if we look at the pKa value for ethanol, my dear students, the ethanol has got the pKa value of 15.9. This value, pKa value of ethanol is more than the pKa value of phenol, and that is why we can say that ethanol is much more weaker acid. Ethanol is much more weaker acid than phenol. So this is even an important fact that we should remember and understand it well, looking at the various pK values for the phenols and ethanols. Now, my dear students, electron releasing group. Now, if on phenols, my dear students, if we have electron releasing groups, then let us see what is the effect of electron releasing group on the phenols. So let us look at the effect of electron releasing group on phenol, or if the phenol is substituted with the electron releasing group, what is the effect? Electron releasing groups such as alkyl group in general decreases the acidic strength. Please remember that electron groups or electron releasing group, when they are connected, when they are bonded, when they are substituted on phenol, the the uh, the acidity of the substituted phenol decreases. So increasing order of acidic strength, if we arrange for the various compounds which are having the substitution of the electron donating or electron releasing group, that is the methyl group, my dear students. So when methyl group is added, or when methyl group is bonded to the aromatic ring of phenol, we come to know that the acidity is being decreased. So you can see here we have the various phenols where the methyl group is present. When methyl group is present in para position, we call it paracresol. When methyl group is present on ortho position, we call it orthocresol. When methyl group is present on meta position, we call it metacresol, and we have phenol. By looking at the pK value, we know that more is the pK value, weak is the acid. So pK value for paracresol, my dear students, is 10.2. pK value for orthocresol is even 10.2. pK value for metacresol is 10.1, and pK value for phenol is 10. As the pK value increases, acidic strength decreases, and that is why phenol is the most acidic among the phenol and various cresol, whereas paracresol and orthocresols are equally acidic and they are less acidic than phenol. This metacresol is more acidic than paracresol and orthocresol but less acidic than phenol. So we can arrange the various cresols and phenol in the increasing order of their acidic strength, and we can say that paracresol and orthocresols are equally acidic. Metacresol is more acidic than paracresol and orthocresol, and the phenol is is uh, is more acidic than all these three: paracresol, metacresol, and orthocresol. Here, instead of greater than, we can simply write equal to. So that is what we can write it very easily. Now we have a question. So whatever we have studied, let us understand it with few examples. Arrange the following compounds in the increasing order of their acidic strength. We have we have propanol, we have 2,4,6 trinitrophenol, we have 3-nitrophenol, we have 3,5-dinitrophenol, and we have 4-methylphenol. So we will arrange them in the increasing order of their acidic strength, and we would come to know that propan-1-ol is less acidic than 4-methylphenol. 4-methylphenol is less acidic than phenol. Phenol is less acidic than 3-nitrophenol. 3-nitrophenol is less acidic than 3,5-dinitrophenol. 3,5-dinitrophenol is less acidic than 2,4,6-trinitrophenol. Now what we have just studied, my dear student, is that the electron releasing group like alkyl group or methyl group, the electron releasing group like alkyl group or methyl group will decreases the acidity of the phenol. So here you can see that by methyl group, the acidity is decreased. So here you can understand it by just understanding the, the simple, by understanding the simple thought that when we have methyl group, the density, when we have the methyl group, the acidity is decreased. But when we have the nitro group, you can see that the nitro group will increase the acidic character. So you can see that when we have nitro group, the acidic character increases. We have even studied that alcohols are less acidic than phenols. So you can see that propan-1-ol is less acidic than substituted phenol. Now phenol is substituted with the alkyl group or methyl group, and that is why the acidity of phenol is decreased, and that is why 4-methylphenol is less acidic than phenol. Now we have the three compounds which are having the nitro group, which actually decreases the which actually increases the acidic state. So nitro group is electron attracting group, and that is why it increases the acidic character. So when we have mononitro, only one nitro group is present, it is more acidic than phenol itself. But when we have dinitro, that means two nitro group, again the acidity is increased, because two nitro will increase the acidity, and that is why dinitrophenol, 3,5-dinitrophenol is more acidic than only 3-nitrophenol. And again, when we have the uh, 3-nitrophenol, that means trinitro group. So 3-nitro group will increase again the, the acidic character, and that is why 2,4,6 trinitrophenol is the most acidic among all this. So when we talk about alcohol, it is least acidic. When the alkyl group is bonded to phenol, it decreases the acidity. And when we have nitro group, this nitro group increases the acidity of phenol. And this is how we can understand the arrangement of various compounds into their increasing order. So now, my dear students, we are going to study a very important and very interesting part of this, which is known as the esterification. So now, my dear students, we are going to study a topic which is known as the esterification. This esterification we have studied even into the 10th standard. So we are all aware that alcohols and phenols, we are all aware that alcohols and phenols, when react with carboxylic acid, they produce esters. But here in this standard, we even need to study that apart from carboxylic acid, alcohols and phenol, if they react with the acid chloride, apart from carboxylic acid, my dear students, if alcohols and phenols react with acid chlorides, you can see here, or even if they react with the acid anhydrides, even if they react with the acid anhydrides, my dear students, they produce esters. So here in 12th standard, you need to study that, or you need to remember that alcohols and phenol, when they react with three type of compound. Number one is your carboxylic acid. Number two, they can produce ester when they react with acid chloride. And number three, when they react with acid anhydride, they even produce esters. So alcohols and phenols, when they react with carboxylic acid, alcohols and phenols, when they react with acid chlorides, alcohols and phenols, when they react with acid anhydrides, they produce esters. This process of obtaining esters from alcohol and acid chloride, from alcohol and acetic anhydride, from alcohol and carboxylic acid is known as the esterification. So let's look at the various chemical equation explaining us the esterification reaction. Let's have a look to them, my dear students. Let's have a look to the various reactions of esterification. Please pay attention to the red box that we are going to study. So here you can see that if we have alcohol or if we have phenol, that reacts with R-COOH, which is a carboxylic acid, in the presence of H plus. This H plus is generally the sulfuric acid taken. So generally when we take sulfuric acid as a catalyst and allow the carboxylic acid to react with the acids or phenols, we get an ester. An ester is produced. Same way, my dear students, when an alcohol or phenol is allowed to react with acid anhydride, you can see here the acid anhydride, RCO twice into O, R dash CO twice into O, which is also known as the acid anhydride. In the presence of H plus, again we need acid, we get an ester and we get another carboxylic acid produced. Third reaction, when phenol or alcohol reacts with the acid chloride RCOCl in the presence of a base pyridine. Remember, the reaction of alcohol and phenol with acid chloride is done in the presence of pyridine, which is a base. So when an alcohol or phenol is allowed to react with acid chloride in the presence of pyridine, my dear students, we get an ester. At the same time, we get hydrochloric acid produced in this reaction. Now, remember, my dear students, that what is the role of this catalyst that we use in this esterification reaction? So here, when we use the when phenol or alcohol are allowed to react with the carboxylic acid, we use sulfuric acid as a catalyst. So why? Because the water produced in this reaction, my dear students, in the process of esterification is absorbed by sulfuric acid, and that is why the equilibrium move, my dear students, move towards the more product. The equilibrium moves towards the more product and we get more and more ester during this reaction. Same way, my dear students, if you look at this, you will find that in the reaction of phenol or alcohol with acid chloride, we get hydrochloric acid. This hydrochloric acid, when it is produced, my dear students, it has to be removed to get more and more product. To remove or to move the reaction, towards more and more product, we use pyridine. This pyridine is a basic substance and this hydrochloric acid is dissolved in the base. Which base this hydrochloric acid is dissolved? This base is dissolved in pyridine, my dear students. So this hydrochloric acid is dissolved in the base. The base we use here is pyridine. So hydrochloric acid is more dissolved in pyridine, and as hydrochloric acid, more and more hydrochloric acid is dissolved in pyridine, we can get more and more product. And this is how we get more and more product. This is how we get more and more ester. So this is the role of the various catalysts that we use for our various reaction here. Now, my dear students, this esterification reaction, we are going to understand, we are going to study using some of the very important examples. So let us understand the esterification reaction using some examples. Let's pay attention to the various examples of esterification. The first example I would like to take is the reaction of ethanol with ethanoic acid in the presence of sulfuric acid will gives us ethyl ethanoate. Same way, my dear students, when ethanol reacts with acetic anhydride, CH3CO twice into O, acetic anhydride, it also gives ethyl ethanoate and acetic acid. Same way, my dear students, when ethanol reacts with acetyl chloride, CH3COCl, in the presence of pyridine, it again gives us the ethyl ethanoate and hydrochloric acid is produced, which can be easily absorbed or which can be easily removed by the base pyridine. So this is how, my dear students, we truly understand the various examples of esterification. Now this is again one very important reaction that we are going to study here. This is again a very important example of esterification reaction. Let us look at this very important example. This very important example is the preparation of aspirin. My dear student, aspirin is a very important drug which is a painkiller and used for few other purposes. This aspirin is a drug that is prepared by the reaction which is known as the esterification reaction. So preparation of aspirin is again the example of esterification reaction. Acetylation of a salicylic acid produces aspirin. You can see here we have salicylic acid, we have acetic anhydride. So this alcohol group, this hydroxyl group reacts with acetic anhydride, that is acid anhydride, and produced an ester, and this ester is known as the aspirin, or it is also known as the acetyl salicylic acid. Apart from this, ethanoic acid is also produced during this reaction. So my dear students, I would like to repeat it once again that as preparation of aspirin is the example of esterification reaction. It is also the example of acetylation reaction too. So this acetylation reaction, this esterification reaction. So when salicylic acid is allowed to react with acetic anhydride, it produces acetyl salicylic acid, which is also known as the aspirin. And this is how aspirin is prepared from the salicylic acid. So this is how, my dear students, we understand the preparation of salicylic acid using the uh, esterification reaction. A very important point I would like to bring to your notice that I have written with the red pen, that the reaction of carboxylic acid and acid anhydride with alcohol is carried out in the presence of sulfuric acid. Please remember. While the reaction of alcohol with acid chloride is carried out in the presence of pyridine base. So we have already studied this fact, but it was necessary to bring it to your notice, my dear students, that you need to remember this fact and answer the questions if the questions are asked based on this fact into the various exams. Now, my dear students, we are going to study a very important topic of this chapter, which is known as the dehydration reaction. So let us study the dehydration of the alcohols. So let us have a look to the dehydration. Let me read for you the meaning of dehydration reaction. What is dehydration reaction? Or what do we understand by the word dehydration? Meaning, removal of molecule of water. Removal of molecule of water is known as the dehydration reaction. So now, my dear students, we are going to study the various or the important dehydration. Alcohols undergoes alcohols undergo dehydration to form alkenes. Alcohol forms alkenes when the dehydration takes place. Alcohol forms alkene when dehydration takes place. How? The alcohol forms alkene when on treating with a protic acid. Example, concentrated sulfuric acid or phosphoric acid, or catalyst such as anhydrous zinc chloride or alumina. So remember, my dear students, that alcohol gives alkene. This process is done by the process known as the dehydration. So the water molecule from alcohol is being removed. This water molecule of alcohol, water molecule is removed from the alcohol by the various, by treating it, by treating the alcohol with protic acid like sulfuric acid or phosphoric acid, or various catalysts like anhydrous zinc chloride or alumina. Alumina is nothing but your Al2O3, aluminum oxide. Let us understand this reaction in detail. First we should see how does it takes place? So you can see here the general reaction for the dehydration. You can see here, my dear student, this is the general reaction for the dehydration. This is what it is, your alcohol. So this is the alcohol molecule. You can see that if there are two carbon present, on one carbon we have hydrogen, on another carbon we have hydroxyl group, which makes it alcohol. This hydroxyl group, in the presence of protic acid like sulfuric acid, when it is heated, the water molecule H and OH combinedly removed from this reaction and we get an alkene. Let us study this with an example. What is the example? Let's look at the example, my dear students, for this particular reaction. So let us have a look to the example of dehydration. The first example that we should study about is the example that is very easy. Example, ethanol, your C2H5OH, undergoes dehydration. Ethanol undergoes dehydration. Ethanol undergoes dehydration, my dear students, by heating it with the concentrated sulfuric acid at 443 Kelvin. So you can see here, ethanol when heated in the presence of a sulfuric acid, which is the dehydrating agent, at 443 Kelvin, we get ethene and a water molecule which is removed from the alcohol. Now let us understand how this reaction takes place. What is the mechanism for this dehydration of alcohol? You know, for dehydration of alcohol, we use sulfuric acid. And this sulfuric acid first turns into H plus and SO4 minus. This H plus, which is a proton, is used for the dehydration. So ethanol actually attacks on H plus. My dear students, we have a limitation of time, so we would stop today's class here. Now if you have any doubt, you can ask me. We will discuss this mechanism into the next class. So dear students, if you have any doubt, you can ask me. Whatever I have explained, do you understand everything? आज
Yes,
मैंने
sir.
आपको जो कुछ भी बताया है प्यारे बच्चों, क्या वो
Yes.
आपको सब कुछ समझ में आया है? क्या आप कुछ पूछना चाहते हैं? बच्चों, क्या आप मुझे सुन पा रहे हैं? ओके। सब लोग बताएं। सब लोग अपने आप को